Okay, hi, this is Baarda with Farming Smarter, and today I'm going to talk a little bit about Farming Smarter's EM38 Soil Moisture Project. So we've got a bit of inclement weather coming in, so hopefully everything turns out okay, but we'll see how it happens. So this project, really what it's about is using this EM38, which is a soil conductivity instrument, as a tool to better understand our soil moisture. So the EM38, it's a soil conductivity sensor, and it does a really good job of helping us understand some soil properties, particularly the presence of clay and the presence of soil moisture. And what's kind of neat about this instrument is it's a non-contact instrument. So this unit, it creates an electromagnetic field, and it measures, so it's a EM induction instrument. So it creates this electromagnetic field, and it measures variations in that field as it's pulled along the soil. So just by putting it on the ground, just like that, I can collect a reading. So we don't need to cause any destruction, maintain contact with the soil or anything. It's a non-contact sensor. So what makes that applicable for in-season soil moisture is ostensibly we can run it through a field at early crop stages, gather maps, and use that to better understand the soil moisture. So on the soil moisture side of things, and the reason we thought this would be a valuable project to dig into is, as a producer, as a farmer, the typical way to collect information about soil moisture is to get out there and use the Dutch auger, so dig a hole, pull out the samples, and evaluate what the soil moisture is. The other major option that's being used out there is to use a soil moisture probe, so an electronic device that's going to accurately measure how much water is there. But the limitation to both of these strategies is one, they only measure the soil moisture at one location, so we don't get a really good sense for what's happening throughout the rest of the field. And two, to get the temporal variability as well. So you sort of have to keep coming back. But the big thing is, one or two locations. I think if you know your field really well, you have a good understanding, what the texture changes are, where it performs well, where it performs poorly. You could identify, a couple critical locations to get that soil moisture information. But in reality, we know that there's a lot of variability in a field. That's in topography. So not only that what moisture is present when we start, when we seed our crop, but also there's variability in rainfall. There's variability in where that rainfall is held and where it moves. There's variability in topography, so how that water moves. So all these factors, you think about, we often treat fields as discrete units, and that's not really the case. It's a good simplification that helps us not overburden ourselves with data and with decisions. But in reality, there are a lot of differences within the field, and especially on the moisture side of things. And you think about micro rainfalls, they don't uniformly affect the field. There is that variability. So that's where this unit comes in. Now, the EM38 has been used a lot in agriculture, and it has its roots probably more in vineyard type production. So when it first began to be used, it was a surveying, to find metals, surveying tool. And as it broke into agriculture, producers in maybe different row crops or vineyards, they could carry it through and stop incrementally and record measurements. And that helped to understand, what the soil moisture might be like, what the texture might be like. But now that we have a lot of the tools, precision agriculture developed a little better, it's a really effective tool that, in a couple of hours, depending on how much you're bumping around and how fast you can drive, in a couple of hours we can have a pretty comprehensive survey of a quarter section, and that gives us a high spatial resolution of what's happening where. So the idea we had with this was perhaps we could use this to make better management decisions. So in our case, we're using a quad. We've got this quad set up here. So we've got the quad, we pull the sled, but a producer, perhaps we could set up something where when you're already going out with your sprayer, you could collect EC data as you're spraying, or when you're performing other operations. I know there are seeders and other implements that are set up with this kind of technology, so we thought that's maybe an interesting idea, an interesting application. So what this could do for a producer is we sort of had two primary ideas for that. And the first would be to better understand soil moisture to direct irrigation decisions. So where in the field is there water? Where do we need to add water? How much do we need to add? How soon do we need to add? And in the case of somebody who has variable rate capacity, what sprinklers do we turn off and on? So how do we, apply the right water in the right place at the right time? And this is a tool that's going to give us, a pretty comprehensive map in close to real time, to make those decisions on the fly in season. The second option would be for variable rate application of fertilizer. So when variable rate prescriptions, often for nitrogen, are built, in many cases, they're generated on the basis of a yield projection. So we look at the field, we look at all the factors we know, what's the soil moisture, what's the variety, how much growing degree days do we expect. So all these factors filter into it, and we come up with a yield goal, a target yield or a projected yield. We say, okay, we're gonna get 60 bushels for this canola. We're gonna fertilize 260 bushels. And if we don't have the moisture to get it, well, then I guess we lose out on that fertilizer. So having an in-season, a little bit more real-time information, some information about soil later in the season should help us do a better job of predicting yield, of projecting what the yield might be. So instead of predicting yield at time of seeding with whatever moisture is in place at that point, maybe 4 weeks in, 6 weeks in, maybe 8 weeks in, depending on the crop, we can go in, we can run an EC map and say, hey, here's what's actually happening in the soil throughout the field now, and these are the areas of the field that have enough moisture to warrant extra nitrogen. So a farmer may be able to put down 60%, 80% of their nitrogen for their target yield, and then we update those yield projections in season and top up according to that. So that, in a nutshell, that's sort of what we're trying to do with this study. So I guess I'll get into some of the details of the equipment we're using and how we're going about trying to answer some of these questions. So it's a 2-year project. The first year was last year. It was a really dry year, and our goal then was just to understand how well this tool works to help us understand soil moisture. So maybe a little bit more about this EM38. So this particular unit, this is a dual dipole EM38 soil conductivity sensor. So an EM38 MK2. So the dual dipole, what that means is it can collect 2 measurements simultaneously. So there's essentially 2 coils within here, 2 dipoles, each of which creates its own electromagnetic field. So if I turn it this way, you can see we've got the full length, and then we've got this piece here, which is a little shorter. So that's our half. So we've got a 1 meter dipole and a ½ meter dipole. So each of these creates an EM field, and each of these EM fields penetrates the soil. So there's some interesting properties to the profile, to the pattern and the way it collects information. So at the 1 meter profile, so this 1 meter coil separation, which will record information, again, every couple of seconds or every second as we go through the field. So the 1 meter dipole, it reaches down about 1.5 meters into soil. So it's measuring the bulk soil conductivity properties 1.5 meters down. But when you look at where that information comes from, the bulk of that reading comes from that top 60 centimeters. So that top 2 feet, that's where the majority of that reading comes from. Whereas the ½ meter is the same thing, it's just cut in half. So you cut that, you go to 0.7 or 75 centimeters, and then the bulk of that comes from the top bit. So really it's heavily weighted. The readings are heavily weighted to that top 2 feet. That's kind of, depending on the crop, but that's a really good idea what the root zone is going to be. So then the other option that we can use with this EM38 is it can also be used in horizontal mode. So if we put it on its side and then again properly calibrate it, it cuts those readings in half. So now we're doing 75 centimeters for the 1 meter dipole, and then 37.5 for the ½ meter dipole. So we did try this, but one of the properties with running in horizontal mode is it's even more heavily weighted to the top part of the soil. So again, when we're running this, we're pulling it in this plastic sled here. So we're a little bit above the crop. There's residual rows from planting. So again, we're not right on top of the soil. So in horizontal mode, you're a little bit above the soil. So a bit of what you're measuring, the most sensitive part of what you're measuring, is going to be collected in that area that's not even reading the soil. So we haven't had an opportunity to really dig into, you know, how that's going to interact with our research project, but we did collect horizontal mode for all of our fields. So I guess that's a little bit about how this unit operates. One of the critical factors with using an EM38 is the calibration piece. Now, when we calibrate, it's so highly sensitive to soil moisture, to metal, to any sort of electromagnetic activity. You have to be a little bit careful about where you conduct a calibration. So I don't have it with me, but we have a plastic stand, and it's a meter off the ground. So we set it on the stand, and we just let it sit. We turn it on, let it rest for about 5 minutes, so it sort of acclimatizes to the environment. And once that's done, we can go in, and basically what we're doing is we're calibrating to isolate out all the latent conditions. So whatever is happening right now, you know, we calibrate out the soil moisture, the temperature, so that we get a relatively standard reading. And operationally, really, if you're using one of these, the recommendation is to recalibrate every 4 hours or so. But if conditions change, if clouds roll in, that's all going to affect things. If you have power lines overhead nearby, you want to stay away from those. You'll see those in your readings. You don't want to calibrate somewhere where the soil's very resistive, where there's not a whole lot of soil moisture. So if there's a roadway that trucks have been driving in and out, there's a lot of compaction, that soil's not going to hold a lot of water. That would be a poor choice for a calibration location. So you kind of be out in the middle of the field, take off your rings, phone, all that stuff, and then we calibrate to isolate out all those conditions. So that's a pretty critical step with the EM38. So what we plan to do is collect measurements every 2 weeks throughout the season, or throughout the early part of the season. So we map 2 fields, we map them at time of seeding, and then 2 weeks after, 4 weeks after, 6 weeks after. So, and once you sort of get into 6 weeks, you know, that's about this time, middle of June, depending on what your seeding date is, you're starting to get crops that, like this would be a little bit too big. You're probably making some damage that you won't be able to recover from. Here we are back at the shop. As you can see, that those threatening clouds did overtake us, so we boogied back over here. I guess we'll find out if lightning affects the EM38. I'll have to look at the data later. So here is our calibration stand. So when we do a calibration, if we're out in the field, you know, we'd set this unit right on here. Set this unit right on here. So it's kind of no metal. I'll take my rings off, take my phone off, and there you go. So it's a pretty cost-effective way to have a nice little stand that you can take apart and pack away. So again, that's a pretty critical part to running the EM38, is having that. Once it's calibrated, we pull this unit off and we tuck her in the sled here. So again, you know, if you take a look, these are just foam, got foam batting. We've got some foam on the bottom. The whole sled, it's a calf sled, it's all plastic, you know, so kind of get in there nicely in the vertical mode. So then we'd map it in vertical. When we're done, again, in our case, we're trying horizontal, but again, I suspect that it's not going to be as much value as the vertical anyways. So we've got, we turn it to quad phase. I've got my cord here. Plug the unit in. So we check battery on it as well. So there you go. So now if we kind of walk back to the quad here. So without getting into too much detail, we've got your normal tractor GPS. This is an FM 750, but any GPS will do. A handheld. You just pull the signal off and then bring it into your computer. Now I've got this logging. There's a couple of things if you do have one and you do have the software. Right here, this is your GPS. Right now we're inside, we don't get a signal, but it tells us that we're searching, so we know we're connected properly. The EM38, you can see these lines here. If I run to the unit and move it around a little bit, you should see the lines kind of jump up and down a little bit. Yeah, there we go. So So as we drive through the field, we can see you know, those readings change, and pretty easily, even when you're in the field, you can identify, you know, where there's compaction, where your low spots are, where your high spots are. Depending on the software you use, you can see a map as you're conducting the mapping, so that's kind of nice. One important tip that's pretty helpful, again, we've talked about how sensitive the unit is and how important the calibration piece is. So one of the things that I do when I map is I map every other transect. So we do 20 meters, 60 feet transects through the field. And if I map every other one and then go back and fill in those spaces in between, that helps me to identify when calibration drift has happened. And that's when conditions change while you're mapping, and that'll cause, you know, again, if the temperature drops by 10 degrees, the sun goes behind the cloud, that's all going to affect the readings of it. So if we do that every other pass, we can identify if the calibration's changed afterward. And that's the reason we have the lid on the sled as well. So it's always in shade, so it does kind of isolate us from some of those temperature changes as well. So yeah, it's not that hard to get set up. It just takes a little bit of technical know-how, but once you're going and once you've got it figured out and the calibration figured out, it's pretty easy to do mapping in it. And I think if you're interested in pulling it with a sprayer or some other equipment, it wouldn't be too tough to do. So again, we've mapped 2 fields so far last year, and we found that, you know, once you get to middle of June, you're starting to cause some damage to the crops. But, you know, we did a field last week. We did new lines on a wheat field, and this week you could hardly tell you were there anymore. So it is pretty non-invasive for the most part. You certainly don't need a big side-by-side. A smaller quad would work as well. So we're pretty excited to see what we can find with it. A lot of the literature suggests a very strong relationship between soil moisture and soil conductivity, the EM38 readings. And I think it is dependent to a certain extent on the soil type you have and how much background moisture you have. You know, if you're well past the wilting point, so your soil is very dry, very resistive, and that's what we had last year. And when we ran through the data after last year, a very, very dry year, drought condition year, it was really tough to differentiate, you know, maps 2 weeks apart. So they didn't change as much as we'd kind of hoped, and a lot of that has to do with the dryness. And again, the correlation with soil moisture wasn't as high as we might have hoped. So often in the literature we see, you know, correlations as high as 80 or 90%. And in some of our past experience, some locations we do see that, some we don't. So there may be areas or fields that are more appropriate for this or not. But yeah, I mean, I guess that's why we're doing the test. And then this year so far, we've had some favorable weather as far as getting one rainstorm, for example, where we got 3 inches of rain in 2 days. So we had mapped before and mapped after. So again, right there, we're seeing some of that temporal variability in soil moisture that we didn't see at all last year. So that's going to give us a little bit more context and help us better understand how this process works. So every time we map a field, we're also collecting soil samples at the same time. And that's a critical piece to any of the EM38 work that's done, is to sort of, you know, get the ground truth piece, so to calibrate what you're reading. So, you know, the EM38 readings might mean something different from one field to the next. So getting some soil samples, getting that moisture content, and a gravimetric will do. So that a gravimetric means you have a prescribed volume of soil, you weigh it wet, you dry it out in an oven at 105 degrees for 8 hours, 12 hours, and then you weigh it dry. And then the difference in weight is attributed to soil moisture. So then we know the soil moisture of every soil sample we take. So what we've done is we've collected those soil samples at our 0 to 6, 6 to 12, and 12 to 24 depths. And this year we added 24 to 36 as well. But again, the moisture profile of the EM38 readings is largely in that top 60 centimeters. But we'll see if we see anything different there. So from a practical standpoint, you know, they advise, you know, 5 or 6 samples would be enough to characterize a quarter section. What we're doing is just about every 5 acres. So we're doing a pretty thorough sampling grid along with it. And the pattern of the EM38 tends to follow the pattern of soil moisture, soil texture. So we can see, the hills and the draws, those are all pretty easily identifiable. So as we dig into the data a little bit more, after this year, we're going to have a better understanding of how things perform. And yeah, we're excited to see, how useful this could be, and how small of changes in moisture can we detect, both spatially and over time. What's the best time to collect that in-season soil moisture? And finally, is that something that we can use to help make better decisions on irrigation management, better decisions on fertilizer application, and better understanding of our fields and their soils. Feel free to give me a call, text, or shout out to me on Twitter, and I'm always happy to talk about what I'm working on. So I guess with that, so this presentation obviously has been pre-recorded, but I am here present and ready to answer any questions you might have at this time. So thanks so much.
All right. I assume you guys can all hear me. Does anybody have any questions about our research into EM38 and soil moisture sensing?
Does the salinity in the soil affect your readings significantly?
Yeah, it definitely would, to the point where that would overwhelm any understanding of the soil moisture. So the salinity really spikes the readings, and it's pretty obvious in a map. In fact, the EM38 is quite commonly used as a tool to map soil salinity.
Well, since nobody else is asking Lewis questions, Lewis, every spring I'm hearing from farmers that are wanting to dribble band or apply fertilizer after seeding is done, and a lot of it's driven by logistical reasons. So I think this year in particular, with the extra rains that we've had, there's so many folks that are going out there with a sprayer or with a spreader. So is the thought then that maybe before making that decision to go out there, and at first, I guess two questions. First is, how does a farmer know that this extra application of fertilizer is actually working? And then second of all, if you don't know that, why would we even take the step to say, do a variable rate application?
Yeah, okay. So that really ties into one of the applications for these in-season moisture maps. And I talked a little bit about it earlier in the presentation. But one of the real applications for this technology could be that better understanding of our soil moisture throughout the field. So ostensibly, once we understand, sort of get the instrument calibrated and we get a good sense for what the baseline soil moisture is, and then we monitor changes throughout the season, that knowing what that soil moisture is, say 6 weeks in, 8 weeks in, at that timing where you would apply additional, foliar fertilizer, I guess that's a pretty critical piece. So a lot of the yield projections, when we decide what to fertilize on our crops, a lot of that is done on the basis of a yield projection, and we really, that's highly subject to what the weather is going to be, especially when you don't have an irrigated environment, right? So this is a tool that helps us better understand, what's the moisture, how many millimeters of water do we have in the soil, and does that warrant, adding a little more nitrogen? So if a farmer were to put down, say, 80% or 60% for their target yield at seeding, then you'd have the option of topping up later. And the variable rate piece comes in where we have fields where that soil moisture profile varies across the field. So there might be areas of the field that are wetter and that have enough moisture to sustain additional crop growth and additional fertilizer. But there might be, say, hilltops that are a little drier where a model might indicate that additional fertilizer would not be a strong economic choice. So this really, what this does is it gives us an extra 4 to 6 weeks to make that decision on fertilizer, and could help us to be a little bit more accurate about being efficient with that fertilizer. So applying it where we know that plants are going to be able to make good use of that based on available plant moisture. Any other questions?
Well, it looks like you did such a fantastic job explaining it, Lewis. It doesn't seem like anybody else has any questions for you. So I really appreciate you taking the time yesterday and today to make this happen. So good job. And we'll see everybody in the next session starting at the top of the hour.
Farmers are at the core of all we do. We help them solve problems by putting ourselves in their shoes. We roll up our sleeves, try new technologies, find ways to increase profits and reduce expenses, and adapt to ever-changing conditions. Our vision is to provide credible news and information to support farmer success, now and in the future. Our publications have deep roots, dating back to 1882. Over the decades, magazines and newspapers like Country Guide, The Western Producer, Grain News, Canadian Cattleman, and more became the place farmers went to for trusted news from award-winning journalists. Today, Glacier Farm Media has developed a strong network of over 40 print and 25 digital platforms, becoming Canada's largest agricultural media company and farmers' #1 trusted connection for independent, unbiased news and information. Our business now goes well beyond publications to diversified offerings that connect in new ways, supported by changing technology, including 3 world-class agricultural events featuring live seed and equipment demonstrations. Using our platforms, we provide data to inform farmer decision-making about seed, equipment, crop protection, succession planning, and more. We stand beside them as a trusted partner and support industry as a conduit to share news about emerging technologies from lab to field. As we look to the future, our team will continue to work hard to predict and innovate to help farmers succeed in an ever more challenging global landscape by bringing accurate information to the field where they need it most. Our vision includes growth in areas with significant return on investment for farmers, such as providing market analysis and developing applications that help them stay connected to the data they need to make decisions. At Glacier Farm Media, our trusted legacy has brought us to where we stand today and directs our vision for future growth as a reliable partner in agriculture, connecting with farmers to inform their business decisions and help them succeed. When farmers succeed, we all succeed.